Good everyone, you are welcome back. Now, from our previous video, we dealt with a three-phase diode rectifier, and then we saw that the output of a three-phase diode rectifier looks like that, right? That is the DC output here. Now, and then we also, from what we did last time, so we saw that the peak value of this rectified signal is √2 VLL, right? Well, this VLL is a line voltage, the line-to-line voltage, right, between A and B, VLL. In other words, it is a VRMS of the input into the invert of the rectifier. Okay, so that is VRMS there. Now, what we are going to do now is we are going to look for the average value and the RMS value of this signal. Okay, so for us to do that, remember from a previous video we saw that the time, all right, the angle between this point and that point, okay, is pi/3. All right. So if this from here is pi/3, now what I'm going to do is, for me to get the average value of this signal, I'm just going to divide this into two. Look at it now. I have that from here to here is pi/3. So for you to solve this, to be able to derive the average value or RMS value, now what you do is we're going to divide this into two, and then we find the average value of this only and multiply by 12 of them, because this will be 12. If I divide this into 2, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of them. Did you get that? Okay, so now remember that here is √2 VLL. Alright? So now what is average value? Okay, average value. Alright, which is your VDC, which is your DC value, right? So DC value is the same thing as 1/2 pi, the integral of 0 to 2 pi, the function omega t with respect to omega t. Okay? So now, but what I want is, I just want from it to here, okay? Then I can multiply by 12. So that means I'm going to write 12 times. Now, from here to here only I'm dealing with. Alright, but with respect to the period. Now, so I'm going to have 1/2 pi, the integral of 0 to from here to here. Remember, if from here to here is pi/3, if you divide pi/3 by 2, you get pi/6. From here to here is pi/6. So I'll get here to be pi/6. Now, with this function, this is a cosine function. It's not starting from 0. If you can start from here, it becomes sine function, but this is a cosine function. So it will be, the peak value is √2 VLL cos omega t, the omega t. Okay, like that. Now, so from here, we can answer, okay, now let's, you can bring this out so that you have, let's just cancel out this, you have 6/pi by √2 VLL. Okay, now when you integrate cosine, you get sine. So I'll have sine omega t from 0 to pi/6. Alright, so that you have 6/pi by √2 VLL. Okay, now into sine pi/6 minus sine 0. Okay, did you get that? Alright, so now once you have that, now the next again, let's just evaluate that. What is sine pi/6? Pi/6, pi is 180. 180/6 is 30. Sine 30, right? Sine 30 is 1/2, right? That's 0.5. Okay, so this is 0.5 minus sine 0 is 0. Okay, times now 6/pi times √2 VLL, right, into that, which is just 0.5. Now let's evaluate that. So I have 0.5 times root 2, let's say root 2 times, you have that to be 1.3505 VLL. Okay, did you get that? So that means that the VDC, alright, VDC for this signal is the same thing as 1.3505 VNL. Okay. Now, what about the RMS value? The RMS value. So RMS value will be what? VRMS for this signal. Okay. Not this one. This is input RMS. Okay. Now we're talking about the RMS of this signal. Now that will give you 1 over 2 pi. The integral, we say RMS means root, means square. So now if I can get the mean, this is our mean, so the root of it and the square of the signal. That's the root mean square, right? Okay, so now I'm going to have that to be as the square root of, now remember, well, I only look for the root mean square of this and multiply by 12. So I'm going to have 12 by 1 over 2 pi, okay, the integral of 0 to pi over 6. Now this function is cos, sorry, I need to put the big value also, root 2 VLL cos omega t, the omega t. But now this is squared, so you must square the whole of that, and then you find the square root. Okay, you get that? All right, so now what we do, now this will give you 6 over pi, and then by root 2 squared VLL squared, okay, into the integral of cos squared omega t. So you are integrating this, cos squared omega t. Alright, now, you remember you put our square root there? Now, this cos squared omega t, so now remember that cos squared x or cos squared theta is half into 1 minus cos 2 theta. Right? Is that okay? Okay. Alright, so now, so we are going to now substitute that in here. So we are going to put what we have there. So that here will be the integral of half into 1 minus cos 2 omega t, like that, from 0 to pi over 6, right, pi over 6, and remember that we still have our VLL squared, we still have our root 2 here squared, and we still have our 6 over pi, and then the square root is there. So now we just integrate this. Let's integrate that. If you integrate theta, if you integrate 1, what you get with respect to omega t? You get omega t, right? So this will be omega t minus, and then if you integrate cosine, right, you are supposed to get sine. Cos 20 is 1 over 2 by 1 plus. 1 plus, right? Sorry, you say 1 plus cos 2 theta, right? Because something is going on here. Now, alright, so this is 1 plus, okay? So, now, cos 2 theta, when you integrate that, you are going to get sine 2 theta. Now, you divide by this 2 there, alright? So, you have that from 0 to pi over 6. And then you are still multiplying by this. Let's just simplify this. Root 2 squared will give you 2, alright? So, that means this will be 2 times this, that will be 12 over pi by VLL squared by 1 over 2. Okay, this 1 over 2, we can even divide that so that here will be 6 over pi only. Okay. Right, so we'll still put our square root. Now, let us put the values here, so that here we give you 6 over pi by VLL squared into pi over 6 minus sine 2 by pi over 6 all over 2, okay, something like this. Then you find the square root. All right, so let's evaluate. So we have, what is sine? This is this divided by that give you pi over 3. Who put minus here? So who put minus here? This is who put minus there. I didn't put it, you put it, okay? Remember this is minus there, is minus there, okay? Now, so now I've put in this value here, here and there to get that. Right? Now I'm going to have, that is pi over 6, and this is pi over 3 minus. Now let's put that one there. If you put one there, is 0. Put this one in here, sine 0 will give you 0. So this is out. So we'll only be left with this, with 6. Right, let's finish it up here. So that this side, so we'll have the square root of 6 over pi VLL squared, right, into pi over 6 plus sine 2 pi over 6 over 2. Okay, so we'll have this. Let's evaluate this, okay? Now, what is sine pi over 2? This is sine 2 pi, right? This is 2 omega, twice of pi over 6, okay? So this is 2 pi over 6, which is pi over 3, all right? Pi over 3 is 60. And sine 60 is root 3 over 2. Okay? So I'm going to have here root 3 over 2 divided by 2 will give you root 3 over 4 minus pi over 6 into VLL squared by 6 over pi, the square root of this. Okay, let's just evaluate this at once now. I hope everything is in order now. All right. So remember, this is plus. Okay. All right. So we have, let's say, root 3 divide 4 add pi. Okay. So you have 1.827 VLL squared, the square root. So if you find the square root of this, 1.827, square root of that, you get 1.35166. Find the square root of that to give you VLL. Okay, so it means that your VRMS, okay, is 1.3517. You can just approximate 1.3517 VLL. That's our VRMS. So I might ask you to prove this. Okay, did you get that? All right, thank you very much.